So today we're talking about right triangle trig. I'm going to draw a right triangle and then we're going to talk about it. Yeah, very exciting stuff. Please don't judge my wavy lines. My hands are shaky. Yeah, that wasn't so bad. Okay, while you're copying, we have triangle ABC. Yeah, I know it's a right triangle. How do I know it's a right triangle? Very good. Everybody sees that little square in the corner. We know that square means 90 degrees. 90 degrees means right triangle. Perfect. Perfect. And we know that for right triangles, they have two legs and a hypotenuse. The hypotenuse is the longest side. The legs are the two shorter sides. So looking at that picture, I know that this side, AC, must be my hypotenuse. Because I can tell just looking at it, it's the longest. Also, I see that it's across from my 90 degrees, and your hypotenuse will always be across from your 90 degrees. That means the other two sides are then legs. We're taking notes. Yeah. So this side's a leg, and this side's a leg. I'm assuming that vocabulary is familiar, but maybe a little rusty. Yeah. Ooh, that's a good question. So that symbol up there kind of looks like the little Jesus fish is actually the Greek letter alpha. And when we started talking about trig last week, we mentioned when we label the size or measure of an angle, we typically do that with Greek letters. So this is the Greek letter theta. That's the most common. This is the Greek letter alpha. Sometimes you'll see a weird curly looking B that's called beta. Yeah. I promise I will write my twos more neatly so it's clear. I don't, for future reference, don't usually put curlies in my two. I usually do them this way. So that'll help in the future. They're labeled that way because we don't know how big they are yet. Yeah. So we know two really helpful things about right triangles. We know SOHCAHTOA. Yeah. Right? We know sine is opposite over hypotenuse. We know that cosine is adjacent over hypotenuse. We know tangent is opposite over adjacent. Yeah. SOHCAHTOA. I'm hoping that sounds familiar. Just practice it. Yeah. The other thing that we know about right triangles is we know that Pythagoras had something to say about the relationships between the sides. I know that if I take leg 1 and I square it, and I take leg 2 and I square it, and I add those two numbers together, I should get the length of the hypotenuse squared. And you probably saw a squared plus b squared equals c squared. I'm not doing that because of the way I labeled my points. It get weird. Leg squared plus leg squared is hypotenuse squared. So we have relationships between angles and sides, and we have relationships between all three sides. Yeah? Those are the tools that we use for right triangle math. And generally, when you're doing right triangle math and you're using one of those tools, there are a couple of steps. The first two should always be the same. So first, you should identify the angle or side of interest. I will write that down in just a second. I got it. Thank you. What am I being asked to find in the problem? Find it in the picture, label it, circle it. Yeah. If it is an angle, you should then label the opposite, adjacent, and hypotenuse. Yeah. So regardless of what we're looking for in a right triangle, first step is just set up. Draw the picture if it's not already drawn. Clearly label the thing you're trying to find, and then write down everything else you're given and label it. Opposite, adjacent, hypotenuse. Stick numbers in the picture for the sides or angles that you have. Yeah. Nice and set up. Once the setup's done, the third step depends on whether I'm asked to find an angle or a side. So we're going to look at those separately. Yeah. Okay. I'm going to take a picture of this. I remember what I said to my first class. Don't judge me. I have to do this again in 6th. All right. Okay if I erase this? Yeah? Okay. All right. So first, let's do finding missing sides. So I'm going to write the steps, and then we're going to do an example. Yeah? And if we're finding a missing side, it depends on what I have in the picture. So if I have a side and angle, I know one of my side lengths. I know one of my angles other than the 90 that I already know. In that case, I'm going to use sine, cosine, or tangent. When we use sine, cos, or tan, we set up the trig ratio, right? Sine of my angle equals opposite over hypotenuse. And I plug the numbers I have, and then I isolate the thing that I don't. We're going to practice. Yeah? If I have two sides. Whether or not I have an angle, instead of using SOHCAHTOA, what should I use? What's my other tool in the toolbox? Yeah. Leg squared plus leg squared is hypotenuse squared. A squared plus B squared is C squared. Yeah. So we're going to use the Pythagorean theorem. Yeah. I don't really want that sitting there. I want that sitting over here. So I have room to do my problem. Yeah. Okay, let's do an example. I guess I should be clear here. There we go. Ooh. I see a right triangle, so I know I'm working with trig functions, and a squared plus b squared is c squared. And I'm asked to find a and b. Are a and b sides or angles? Sides. I'm asked to find some side lengths, right? These are the things in the picture that I want. I'm given an angle. I see a labeled angle in the picture. I know that I have 30. So for step 2, when I label my triangle, I'm going to label the sides relative to the angle that I have, which is 30. So second step, I know what I'm looking for. I know what I have. What side is opposite my 30 degrees? A, yeah. A is my opposite. It's across from. I'm going to label that up. Where's my hypotenuse? Yeah. Longest side across from the 90, which means B must be my adjacent. Right now, in my picture, looking at that picture as it's labeled, should I be using a trig function or Pythagorean theorem? Do I have a side and an angle or two sides? What do I currently know in my picture? Side and angle. I know my hypotenuse is 10. I know I have a 30-degree angle. That's a side and an angle that are known, which means I have to start here. I don't have enough information to use Pythagorean theorem. Yeah. Looking at SOHCAHTOA, sine is going to be a over 10. So I could find a first. Cosine is going to be b over 10. Could do cosine first. Tangent is op over adjacent, a over b. Is that helpful right now? No, because that's going to be two things I don't know. So let's start with sine. We'll do SOHCAHTOA in order. I like that. So we'll start with sine first. We're going to set up our sine function. So sine of 30 degrees equals, opposite is A, hypotenuse is 10. Want to solve for A, I got to get rid of that denominator. So I probably should multiply both sides by 10. So I get A is 10 times sine of 30. And then you're going to grab your calculator and you're going to give me that answer out to like 2 decimal places. Make sure your calculator's in the right mode, because we have 30 degrees, it's not 30 radians. Ooh. I got a nice pretty number. Did anybody else get a nice pretty number? I see some nodding. Cynthia, what'd you get? 5. Yeah. The sine of 30 is 1/2. Yeah. Yeah. Perfect. I'm going to go label that in my picture. I now know side A is 5. 2 sides in my picture. Halfway done. Yeah, halfway done. This was the first thing I was asked to find. I'm also asked to find B, second side length. Looking at my picture, I now have 2 sides and an angle. So I could use the 2 sides and Pythagorean theorem, or I could use one of the sides and an angle with a trig function. We have a choice. I'm going to do Pythagorean theorem as a review so you remember how it works. You could just do cosine of 30 at this point and get B quickly. That's also fine. I want to do a review. So for B, I'm going to set up Pythagorean theorem. So it's leg squared. First leg is 5. Plus second leg squared. Second leg is B. Equals hypotenuse squared. So 5 squared plus B squared is 10 squared. We're going to simplify. 5 squared is 25. Can't do anything with B squared. 10 is 100. Yeah, I heard subtract 25. I agree. So cancel that guy, minus 25. So we get B squared is equal to 75. I see nodding. That's good. But I don't want B squared. I want B. How do I undo squares? Square root. Yay. I take a square root of both sides. So I know B is going to be something, but I don't want to write square root of 75. And I prefer not to write a decimal if I don't have to. So I'm going to simplify that off to the side. So off to the side, looking at square root of 75, I'm going to start checking if perfect squares divide into 75 evenly. 4 is the smallest one that I can use. That's 2 squared. Doesn't fit in evenly. 3 squared is 9. Doesn't work. 4 squared is 16. Doesn't work. 5 squared is 25. Does 25 fit in evenly? Yes. So I'm going to split this guy up into square root 25 times square root of 3. 75 is 25 times 3. What is the square root of 25? 5. Yeah, this guy's just going to become 5. So my answer in reduced radical form is 5 root 3. Happy face. Yeah. Sometimes in Delta Math, they're going to say give a decimal answer, in which case you can just shove square root of 75 in your calculator. If they say exact or they say reduced radical, they're looking for this. So go through that reduction process. Yeah. For your homework, if you struggle with that, you can come see me. There are websites that can help you reduce. You just type reduced radical app, right? But by test day, we should be able to do that. So if you need more practice, come see me. I can get that for you. Yeah. Okay. One more thing. Yeah. One more thing. Maybe if I can get my picture taken. Okay. So we need to practice the last skill, which is we know how to find missing sides. How do we find missing angles? Yeah. So for missing angles, remember we've done steps 1 and 2. We've got a labeled triangle. We know where opposite adjacent hypotenuse are. Yeah. We know where our missing angle is. So for this, we're going to set up the trig function that involves the two sides that I know. Because to do a missing angle problem, I have to know two sides. If I know opposite and hypotenuse, I'm going to use sine. If I know adjacent hypotenuse, I'm going to use cos. If I know opposite and adjacent, I'm going to use tan. So steps 1 and 2, that labeling is important. Make sure which sides have numbers attached, which sides don't. Yeah. So at this stage, we have something that looks like sine of my angle equals a fraction. Sine of theta equals 4/7, opposite over hypotenuse. Yeah. And the question is, how do we undo a sine function so that I can get at the thing inside the sine function? The answer is we use the inverse function, right? To undo addition, we use addition's inverse, which is subtraction. To undo a square, we use a square root, which is the inverse of squaring. So I need the inverse of a sine function, which is sine inverse. So at this point, what I would do is I would do a sine inverse of sine of theta equals a sine inverse of 4/7. We're using the inverse trig function. And the reason we do that is sine inverse and sine are going to undo each other and leave me with the thing that was inside of the sine, the missing angle. So for that example, I'm left on the left with just the angle. On the right, I'm left with sine. Ooh, nobody told me I was missing my 1 right there. I'm left with sine inverse of 4/7. And one of two things is going to happen here. If this fraction, 4 over 7, appears as one of the coordinates in your unit circle. If you can find it, sine is my y, so I'm looking at y coordinates. Do I see 4 over 7? If I do, the angle that goes with that fraction 4 over 7 is the angle. Most of the time, that's not going to happen. Most of the time at this stage, what you're going to do is use your calculator. And on your calculator, if you look above the sine, cosine, and tangent buttons, in blue, you should see sine inverse, cosine inverse, tan inverse. So we're going to do this together. On our calculator, we're going to press second sine. And when you press second sine, you should get sine inverse in the opening parentheses. And we're just going to type 4 divided by 7. Yeah. And I get 34.8 degrees because my calculator is in degree mode. If your calculator's in radian mode, you're going to get a much smaller answer. When you use inverse trig functions, it's going to spit out the answer in the same units that you have your angle set to. So if your angle is currently set to degrees, like mine is, it's going to spit out a degree answer. If your calculator's in radians, it's going to spit out a radians answer. So if you want to know the units that go on your angle answer, check the units that your calculator is set to. Those will match. Yeah. Let's do one from scratch, and then we'll do our team task. Yeah. All right, we're going to go through the whole step list. We'll start with step 1. Step 1, identify what we're looking for. What are we looking for? Theta, an angle, yeah. I'm looking for this. This is the thing I'm finding. Step 2, label everything that I have. Numbers are in the picture. I should label opposite, adjacent, hypotenuse relative to that angle I circled. Andres, can you tell me which side is opposite that angle we just circled? Perfect. It's across from that angle. That must be opposite. Natalia, where's my hypotenuse? The blank spot. Yeah, it's the one that's unlabeled. Good. That's the one across from the 90. That's our longest, which means the third side, which is labeled 4, must be our adjacent. Very good. Looking at that picture, I have the opposite side and the adjacent side. According to step 3, I choose the trig function that goes with that. Ooh. Abner, which trig function should I use when I have opposite and adjacent? Tan. Perfect. Tan is opposite over adjacent, so katoa. So we're going to set up our tan function. Tan of theta, opposite is 3, adjacent is 4. Perfect. Very good. And then we'll see who's paying attention. Christian, how do I undo tangent? What should I do? Ooh, Cotangent. Cotangent's the reciprocal. That would undo the fraction on this side. I'm focused on the left side. How do I undo tangent? Here, I saw you shaking your head no. Inverse tan. And I'm glad you mentioned that, Christian. That's really important because that happens a lot. Reciprocals are different from inverse functions. Yeah, when I say inverse, we want tan inverse, not cotan. So inverse and reciprocal are not the same thing. Good, so we're going to do tan inverse. I know on this side it's just going to cancel and give me theta. On the other side, I'm going to get tan inverse of 3/4. Last step, Natalie, what do I do? Very good, put it in our calculator. And it's probably going to give us a rounded decimal. I'm going to give my answer in degrees because that's what my calculator is set to. And I get 36.9 degrees rounded. I see at least one person nodding, which is a good sign. Yay. 2 seconds. Okay, so my hope is that none of this is groundbreakingly new because I taught math 2 before. I know this is math 2. At some point, you all saw this as sophomores. So today is a refresher course on what you did as sophomores, and then Friday we're going to add to that a little bit for the calculus trig part, yeah, or the college trig part. Words are hard. Okay, I'm going to stop that. So today we're doing a team task. I'm going to walk you through it briefly. Each table is going to get a worksheet. I have 4 different problems, so each table is going to get slightly different. Yeah, every person at the table is going to get the same worksheet. Yeah, because I want you to work together. There's a lot of problems on these worksheets. You can probably see. I don't expect anyone's going to finish in class. Your goal is to get through as many as you can. Yeah. After I've passed these out, I'm going to pass out whiteboards and some dry erase markers. All of the scratch work you guys do to solve these should go on the whiteboard because you should be working together. Yeah? At the end of class, you're going to take 2 pictures. Everyone's going to get a picture of the team whiteboard. And then every individual is going to take a picture of their own worksheet. 2 pictures. Team whiteboard, individual worksheet. Those 2 pictures go to Canvas. There's an assignment in Canvas that's titled Team Task for today. Yeah? Okay. I didn't stop the recording.